All right, what we're going to cover today is collections, formatted output, and Lambda expressions. Collections are something that we use a lot in .NET. So moving forward, you will be using them a lot, not only in this class, but in our upper level CIT classes. And basically a collection lets you create dynamic objects that increase or decrease in size. They are classes that we can use that have add methods and remove methods, clear methods. They have count properties to tell us how many items there are. There's actually a lot of similarities between the different collections, but how those collections work internally is quite different. And so we're going to be taking a look at quite a few of them today. And there are several programming examples that I have to show you to hopefully get you into the hang of working with these collections. And I think once you've worked with a couple of them that you're going to have a better understanding of how to create an object from a collection, and then, how you can add and remove content, how you can find content, how you can display the values, all of that fun stuff. So we're going to start with probably the most popular collection, which is the list. And this is something that we looked at in the 110 class. A list is very similar. You can kind of look at it as a dynamic array. An array has a very specific size, and you can't exceed that size. And a list has a type just like an array does. And you'd be storing items that are all of that same data type. But the cool thing about a list is that the size is going to change when you add items and when you remove items. So the size will increase or decrease depending on how many items are in the list. So it is dynamic. And to create a list, the syntax is you're going to use the keyword list. You're going to give it a data type. You're going to give your object a name, equals new list. Going to give it a data type. And then if you want to initialize it with some seed value, you can. Okay, but there are add methods that also let you add data to the list. So I've got some examples. Here would be how we would do an integer one. And then you can see here is a string list. Some of the properties and methods that are available in the list class, I have listed here. And we will take a look at how to use them. For the list class, I did go into a lot more detail with how to use all of these different methods. You'll notice that for the other collections, I didn't go into as much detail. I'm going to give you the table that kind of summarizes everything. And then I've got some coding examples for you to look at. Because honestly, after you do one of these, it becomes familiar. I wouldn't say it becomes super easy, but it's going to be familiar to you. So for adding data, obviously we can use an initializer list. So if we choose to do that in curly braces at the very end of the statement, we give it the values that we want to put in the list. And, they can be numbers or strings or, whatever data type you have specified. There's also an add method that you can use where you just take the list object dot add, and then in parentheses, you give it a value. Now, if the value is stored in a variable like this one, you can use the variable name and pass that to the add method. Okay, so it can be a hard-coded value. It can be a variable name. You could also, in this case, because it's a string, I could read a string from the console and pass that on to the add method. Okay. So the only thing that it's going to require is that it's the correct data type. The insert method lets you add at a specific index. So you have to give it the index, a comma, and then either the variable name or the value that you want to add. Okay, and remember that the index starts at 0. So if I say I want to insert something at index 2, that's going to be the third element in, because the first one is 0, then we have 1, then we have 2. If I say I want to put something at index 0, that is the beginning. Okay, that would be the beginning of my list. Adding a range is fairly easy if you put the values for the range into an array. So you can see I have my original list, and then I created a little array. If you do that, you can use the list object dot add range, and then in parentheses, you can give it the name of the array. And it will add all of those items that are in the array to the end of the list. Okay, and so this example is showing you strings, and then here's one that's showing you integer. The count method simply counts the number of items that are in the list. And if you wanted to display the items, you can either use a for or a for each loop, and then write to the console. The list collection also has a sort method and a reverse sort method. So you can sort, going forward or backwards. And there are several different ways to remove content. Clear, that method is available in all of the collections, and it erases everything. All of the collections also have remove. Okay, and remove is going to get rid of the item that you specify. So if you specify the value that's stored, it'll get rid of that. If you specify the index number, it gets rid of the item at that location. Now, if you use remove at, all it wants you to pass is the index number. For a remove range, you're going to give it the index number where you want to start removing items, a comma, and then the number of items you want to get rid of. So I do have an example that we can copy and paste into Visual Studio, and we can run it. And I'm just going to make sure. Okay, so sometimes the web browser strips off my angle brackets for my data type, which is not ideal because I have to have them. That looks like they're in here. So I'm going to go ahead and run this. All right, so let's see what it did. So we started out with our list. We have an initializer list. And then we created a little variable and we added Pete. Okay, and so he would have gone to the end of the list. And then we added Clarabelle to the beginning. And so then you can see we've got Clarabelle all the way through Pete. And then you can see that we have an array here. And we added that range. Okay, and so now we have 10 people in. Okay, and that's where we printed. So you can see we've got Clarabelle at the beginning. You can see where we have Pete. And then after Pete is where those 4 new ones were added. Okay, now we're going to remove Pete. And we're going to remove the member at index 4. So 0, 1, 2, 3, 4. So Pete and Daisy are going to be removed. Then we're going to remove, starting at index 3. 0, 1, 2, 3. We're going to remove Donald and Goofy. We're removing 2 items starting at index 3. So I would expect when it prints that these 4 are not going to be there. So here's the revised list. And if we double check, they are no longer in the list. And then you can see we sorted in ascending and descending order. So as you can see, it's really not difficult to use these methods. I think it's pretty straightforward, especially if you have examples to look at. Okay, and so here's a similar example, but instead of a string, we're using integers. I have another example here, and this one is double. So with this one, because it's a balance and checks, I did do some formatted output. And I did cover this in the 110 class, but I'm not sure how many of you remember it, or maybe your 110 class didn't have formatted output. So I did include some information on that. So you have to use string.format, okay? And then it's a 0, okay? And that kind of goes with the variable that you're going to be printing, and then your format character. So you can do a C for currency, E for scientific, F for fixed point. The N is for the thousand operator. You can also do custom formatting. And so you can see up here, they all start with 0. And that kind of goes with the value back here that I'm going to print. And then I did some custom formatting. So here I've got the commas, the thousand separator, and here I just have the 2 decimals. So if we ran this, you would see that the output looks pretty good. A lot better than a bunch of trailing decimal places that aren't formatted. Okay, so the name of the account. And how many checks? Okay, so you can see where I've specified the thousand place. It's showing. I did not specify it here. Okay, I just specified the 2 decimals. But I could have changed that. Now that I can see that, if I wanted to, I could come in here. This is the one where I did not specify it, and I could put it in. It just depends on how you want it to look. Or I could do this, okay, and have it do currency. So let's see what that looks like. Oop, gotta put a valid number. Okay, so you can see when you use the currency what that looks like. And I could have used currency for all of them if I wanted. Okay, and currency is probably easier because it's just a C. And if I wanted the thousand separator, could have done currency up here. Could have done the thousand separator here. And then I could have done currency down here. And that actually probably give me the best output. Okay, so we'll shorten this up to Fred here. We'll do 2 checks. Okay, and so you can see what. And so that brings me to a sorted list. So we looked at the regular list. A sorted list is similar, but when you add items to the list, they are added in sorted order. So that list is maintained in the proper sort order. So what that means is that you cannot have duplicate keys. The keys have to be unique. Does not matter what the value is. The value can be duplicated if it needs to be, but the key is what's important, and that has to be unique. Internally, C# is maintaining two arrays. One is for the keys and the other is for the associated values. And the capacity of the list is the number of key value pairs that it can hold. If you wanted to convert a sorted list into a dictionary, C# does allow you to do that. You can typecast a sorted list into a dictionary. How do you create one of these? So I've got a couple examples. The first one, there is no initializer list. And for the second one, I do have an initializer list. And you can see the type for the key is listed first, and the value is listed second. And that is up here. Okay. And it does not matter what data type you have for the key. It's your choice. And it doesn't matter what the type of data is for the value. It's just that whatever you list first is going to be your key. And then you're going to have a name for your list object. And that's pretty much how you create it. Properties would be capacity, how much it can store. And the interesting thing about the list is that the default is for 4 items. And the minute you add a 5th item, it automatically increases the size by 4 more. So it increases the size in increments of 4. Okay. There's nothing really special you have to do. That is what happens behind the scenes. If you're curious about the number of items, you can get a count of the items. Okay. You can also retrieve the keys. You can retrieve the values. You can see that we have methods for adding. I already mentioned the clear method that erases all the data, and that's available in all the collections. Anytime that you have a key, there is always going to be a way to check for the key to see if the key exists. There's typically a way for you to check for a specific value. Okay, and so you can see all of the different methods, the add methods, the remove methods, and then the methods that deal with retrieving and checking keys and values. For our collections that deal with keys, when you have a for each loop, you will be retrieving a key value pair. So the for each loop is going to be a little different. So you're actually going to use the keyword key value pair. And then you're going to give it the data type of the key and the data type of the value. Then you'll give it the alias that you are going to use while you're in the for loop. And you'll say in, and then give it the list object name. So in order to access the key, it's going to be your alias.key with a capital K. And to access the value, it's whatever the alias is .value with a capital V. So in this little example, you can see that we have kind of declared our sorted list. Very original name. We're calling the object sorted list. And then you can see that we've got a bunch of adds. So first thing we're adding is the key, which is an integer, and then it's a string. Then in order to access the items that are in the list, we're going to do a for each, which is going to return a key value pair. So we've got key value pair, and we have to tell it the data types. And then my alias is the letter L in sorted list. And then for my key, I have to use L dot key, capital K. For my value, I have to use L dot value. So here I did a bucket list. And so my key is a string and my value is a string. And so you can just kind of see how I went about doing this. I used the add method to add items. I've got my for each here. My alias is BL for bucket list. And so I've got BL.key, BL.value. And then if I'm allowing them to enter data, I'm going to have them enter the city and the country. And remember, let's see, it's the country that is my key. So here I am, first of all, checking to see if they have already added the city. Because if the city is already in the list, then I'm just going to tell them, hey, the city is already in your list. Okay. If the city is not in the list, then I need to get the country. So I'm going to check to see if the list already contains the country because I can't have a duplicate key. Okay. And so here I'm saying you can only visit one city from a country. Now, what I could do is I could have removed that country and city and just added the new one. Okay. But I chose to do it this way. And as long as the city and the country are not in the list, then I can go ahead and add and tell them it was added to the list. Okay, so here, let me run this so you can see. All right, so here are my key value pairs. What city would I like to go to? So let me do Paris. Country. So this is going to be a problem because France is already in my list. Okay, the way I have it right now, they would not be able to add that. So I could adjust this and I could remove that combination of France and Keynes and then add the new combination. Okay, so I've modified this just a little bit so you can see. Now, if they enter the same country, I'm telling them you can only visit one city from that country, and I'm removing it. And then I'm adding that country with the new city, and I'm telling them, okay, so I've gone ahead and added your current city and country in France or wherever has been removed, and this new city has been added. Okay, and then I'm also printing out the list again. So let's run this. And what city would you like to go to? We'll try that again. I'm going to do Paris, France, which is already Paris or France is already in my list. You can see that. So now it is displaying that information, and you can see that it did remove the old one and insert the new one. The next collection we're going to take a look at is a queue. And a queue is a special type of collection where items are placed in a first in, first out style. And you guys do need to know how a queue works and how a stack works for your certification exam that you will be taking in a couple courses from now. So a queue is first in, first out. which kind of makes sense if you think about standing in a line. So if you're standing in a line and people line up behind you, you are going to be served first because you are at the front of the line. So first in, first out. Kind of makes sense. Okay. And so the queue contains the elements in the order they were added. Okay. And so here is a little illustration. You NQ the items, they go into the queue, and then when they reach, the end of the queue, they're dequeued or they are removed. When we are working with a queue, if you need to add items, you have to use the NQ method. You cannot use an initializer list. And to remove the item, you're going to use a DQ method, or you could use a peek method. Okay, there are not nearly as many properties or methods that are available with a queue. Okay, you can see we don't have all that many, although we do have clear, which is in every single one of these collections. And for properties, we also have count, which is also in all of these collections. But I did do a little example that kind of shows you how these methods work. And so I've got NQ, I've got peek, and I have DQ in here. And then I've also included a for each loop so that we can view the contents of the queue. And so here we've got a string queue that I'm calling members. And you can see I couldn't do an initializer list here. So I am NQing a couple members of our member object here. Then I am prompting the users, how many members would you like to add? Okay, and so here I am, allowing them to enter as many members as they wanted. And then I'm doing a little count, so you can see how that works. And then I'm displaying the contents, which is a pretty straightforward for each loop. If you want to view the first item in the queue and display it to determine if you want to remove that person or not, or that object item, here is how you view the person that is at the beginning of the queue. It's just the queue object.peek. You can see I'm storing it here. And then would you like to remove that person? I'm asking yes or no. And if they say yes, DQ removes them. Okay, and then I'm taking another look at the next person. Would you like to remove that person? And then I read in their answer, and you could actually remove everybody from the queue doing this. Okay, and then if at the end of this, if there is nothing left, if it's null, that means the queue is empty. Otherwise, I'm going to show them how many members they have left in the queue. So let's take a look and see how this one runs. So here we go. And we'll try to run it. Fingers crossed. Oops, I can see I didn't get my U up here. Let's go. How many members would I like to add? I think I'm going to do 2. So we got Mickey and we got Minnie. I think I'll do Daisy, Duck, and Donald. Okay, would I like to remove Mickey Mouse? Sorry, Mickey. Would I like to remove Minnie? Sure. No. Okay, so that is pretty much how that runs. The queue is actually pretty simple, not a whole lot of methods or properties to work with. Priority queue. So for a priority queue, it's not necessarily first in, first out. It's kind of like the items in the queue are kind of triaged, and so some are given a higher priority than others. And the higher priority items are the ones that are removed from the queue first. Okay, so when you create a priority queue, you're going to give it a value like you did before, but then you're also going to give it a priority number. Okay, and so the lower the number, the higher the priority. Okay, so here you can see I've got a string value and an integer number that I'm giving. And then here I've got an example. This is a message object. Here I have a hospital object where I'm actually, I have a patient class, and then I've got the priority number that I'm going to give it. And you can see that here is how I am using the initializer list. I didn't use one with this one. So again, there's the count property. It will retrieve unordered items. Okay, but you can see that the clear method is available. We can dequeue items and we can unqueue items. You can unqueue and dequeue, so it'll get rid of the highest priority and add a new item to the list. And you can try to dequeue and you can try to peek. And these are a little safer because they aren't going to throw exception errors. So we'll look at a really simple one first. This really simple one is just like a little message queue. And so we have a string and we have a priority. Okay. And so, and you know, things can have the same priority number. Okay. And so you can see that we have a couple things here with the same number. Here it's going to give us a count. And then here it is going to go through and try to dequeue each item. And when you dequeue, you can see that you have a couple values that you can display because it's outputting a string called item and it's outputting an integer called priority. So I can display the contents of item and priority. So let us look at this one. And we're going to keep special focus on the order here. Slitty and the word and have the same priority level, but they're not right after each other. So let's kind of watch those. 6 items in the queue. So first it got rid of my number 1 items. And then it got rid of my number 2 items. Okay, so it kind of jumped over the, and then lastly, it got rid of the priority 3 items. Now this next example is a lot more realistic, but with realism comes a little bit more complication. So this is a patient class. Tried to do it as simply as possible. We just have a name and an age and a parameterized constructor. That is it. Okay. So not a whole lot going on in this patient class. Then in the main method, we are going to create a patient list. Okay. And so you can see that we're using our patient class here and an integer. So this, when we have new Sarah Jones, it's going to run it through the constructor. Okay, so all of these are being run through the constructor. This integer represents the priority. Okay, and all of that right now is not in a priority list. It's just in a regular list called patients. Then I'm going to create my priority list or my priority queue. So I've got hospital queue equals new priority queue, patient class and integer. And then here's the data. It's in this patient object where I've got my patient class information and I have the priority. Okay, so that's giving me some seed values. Then I'm going to display a little menu where they can add a patient, view the highest priority patient, and treat and discharge, or they can quit. Now, the problem with the priority queue is that you really only can view the highest priority patient. Okay, so that's, I mean, you're not going to use this kind of collection unless you need to prioritize things. So hospital is a perfect example. So we've got our little menu. It does allow them to add, which means that we could add a patient with a pretty high priority and they're going to jump up in the queue, which is just like real life. So we can add the name, we can add the age, we can ask for a priority, and then we can unqueue the information. So we've got new patient where we will pass name and age, and then we have the priority. Okay, so that can be added to the queue just like these items were. Okay, and then if they chose a 2 from the menu, we are going to check for the patient with the highest priority. There are 2 ways to check this. We can use peak, or we can use try peak. Try peak is safer because it's not going to throw an exception error. So here's the code for peak, okay, which I commented out. And here's the code for try peak, which is safer. Okay, so you can see that for output, I've got next patient that's being output. And I've also got the patient priority, which allows me to print out the next patient's name and their age. Okay, because I wanted the highest priority patient. So I already know that they're, going to be the next person treated because that's what try peak and peak retrieve, highest priority. As far as discharging and treating, that is DQ. DQ is going to remove the highest priority item. So we've got DQ and we've got try DQ. Try DQ is safer. Okay, so here's the code for try DQ. I have the code for regular DQ commented out. For try DQ, I'm getting a object for the patient they discharge and the priority. So I can actually print out discharge.name and discharge patient.age to display who we removed from the queue. Okay, and if they chose something else, they get a message they made a bad choice. And then we display the menu again. So I'm going to show you how this works because it is kind of cool, especially in an example like this. Okay. So hopefully all of my angle brackets are there and the browser didn't get rid of any. All right, so I got through all my seed data. And so if I want to view right now the patient with the highest priority, it's going to be looking at these 5 people. And Elizabeth Lachlan should be my highest priority patient because she is number 1. And she is. So let's treat and discharge Elizabeth. All right, now let's see who our highest priority patient is. Joe Schmo. Let's add a new patient. It's a bad day for the Schmo family. Let's see. Row Schmo. Row is 36. Let's see. Row is not having a good day. Let's put her or him at 1. All right, so now let's look at the highest priority. It is Row Schmo. Let's treat and discharge Row. Okay, so you can kind of see how that works. It is kind of cool. There's just kind of a lot of moving parts here because we have a class along the class object is basically the data that we're storing. It's our value, and then we've got the priority. And at this point, I'm going to stop and I'm going to do another video for the second half.